Hello. Oh, you can hear me, but you can't see me. One sec. There we go. Now you can see me all the time. Welcome to JavaScript with Joe. Today we're on day 6. Let me close this unprofessional cupboard and let's get ready to rock. Let me shrink this down so I'm not covering all of the code. I'll just pop myself in the top right. There we go. All right, this is looking a bit more JavaScripty. So, as usual, we're doing day 6 of Advent of Code. We're trying to do it every 4 p.m. every Wednesday, though I've missed that by a mark. I had a couple of meetings today, so I had to wiggle it. But I did just leave the meeting early to come here, so you're all very welcome. What I'm going to be doing is just, well, I'm trying to keep it for beginners, but obviously these challenges are really, they're quite taxing. The last 2 weeks, I haven't managed to get any of them done. So, it's possible we don't finish it, but that doesn't mean it's not educational. That doesn't mean that it's not actually what development work is like, right? You can't just set yourself 1 hour for a task and have it always work. So I think it's equally as useful to show what happens when all the big red errors come up and how to deal with them. And I'll try to balance that. But yeah, today we're on day 6. I'll read through this in a bit, but I have pasted it in the chat as well. Hello, Sidiqua, I think. Thanks for coming. I hope you enjoy this. I guess if you're in the chat, let me know, what level of programming knowledge you have. How long have you been coding? How long have you been coding in JavaScript particularly? And I'll try and aim it at your level a little bit more, and I'll try and slow things down a bit. But as I say, this is recorded. This is on YouTube. I'm going to move that off so I'm not just streaming all the YouTube chats actually. So I can still see it, but that should be everything. So let's get started anyway, but I've got the chat somewhat open on my other screen as well, so I can I pop out? There we go. Yeah, so I've got the chat open on the other screen now. Anyway, apologies for the late start. We definitely won't run any longer than an hour, so we'll probably wrap up around 5:30 if I can't beat the challenge. If we beat it early, I'll finish it early. But yeah, let's get started. So this is Advent of Code, if you're not familiar with it. It's 25 programming challenges. You try and unlock the stars. You can see that I got all of the stars for the first 3 days. I haven't been able to do 4 and 5, and today we're doing day 6. They'll have a somewhat strange challenge that I'll talk us through in a second, and it always has 2 parts. So usually the second part will punish you if you cut a lot of corners in the first part. And then I'm using Repl it.com, and this is just somewhere where you can write some JavaScript code or Python code or a bunch of other languages without actually needing to set up anything yourself. So we couldn't use this last week because the internet was doing some strange things, but this week we are allowed to run some JavaScript. So on the right hand here, you can just type some code into what's called a REPL, and this stands for read, evaluate, print loop. So you can see there I've typed in 3 plus 3. JavaScript will read that in. It will evaluate what 3 plus 3 is, which we know is 6. It will then print out that evaluation. As you can see, it's showing me it will do, but if I press enter, it will actually do it, 6. And then the L stands for loop, so it'll just keep asking us to do that over and over again. So we can add things together. We can do 3 minus 1. We can multiply 2 numbers, like 3 times 3. And we can divide using the slash. And this has some quirks to it because we're on a computer instead of, I guess all maths is a computer. But yeah, there's some quirks there, but hopefully you won't have to touch them. But that's how you can get started. So that's how you can see, that you've got something working here. The next thing we have is a notion of variables. So in JavaScript, we could save something into a variable. So I could say variable my age is equal to 27. And then we have access to that variable whenever we want it. So we're basically, I always describe it as, if you're moving houses, you might pack all of your kitchen things into a box, and you might describe that box as kitchen, right? You might write kitchen on the side of it, or bedroom, and you know that all the contents of that box are referred to by that name, that helpful name, right? That's how you know where to put that box. It doesn't really matter what's in the box. You don't have to number it. You don't have to call it box 17. It actually has some meaning to you. So that's the benefit of these things. So if it was my birthday, for example, I know that my age will become my age plus 1, right? I might describe it as 27 plus 1. I might just describe it as 28. I probably would describe it as 28 if I was communicating with anybody, actually. But, you know, these kind of concepts of my age plus 1 do make sense in that world. So yeah, that's the first sort of big useful thing in programming, that you can store information in a variable name for later. The second useful thing is what is called functions. You can write, again, meaningful named blocks of code that will do something. So we could do something like, is it const, I don't know, add year, which will take a birthday, or let's take an age actually, which will take an age, and it will return that age plus 1. Ooh. Do I need to write func or something? Const. No, I need to write equals. So as we used up here, var my age equals 27, that's called the assignment operator. So it's not saying my age is equal to 27, it's actually storing the value 27 in my age. So we're doing that here, const. That's not going to work either. What do I need to write here? Const. I'll write a quick arrow function in JavaScript. Function. How do I name the function? Do I do const? Const add year equals. Can I do it like that? There we go. Add year. That can take an age, so we can give it my age from before, and we see it returns 28. So we can just store little bits of logic like that. Add a year to my age. Unsurprisingly, we get my age plus 1 year. It all makes sense. We've done a little bit of maths. It's kind of hidden in some interesting names, but we've chosen names that make that useful. So these are sort of the two building blocks of all of JavaScript. So we've used about 5 minutes to explain that. Let's hop into Advent of Code and actually get started. So day 6, Lanternfish. The seafloor is getting steeper. Maybe the sleigh keys got carried this way. A massive school of glowing lanternfish swim by. Oh, very cute. They must spawn quickly to reach such large numbers, maybe exponentially quickly. So this is probably a clue that we might have to do something computationally clever to actually deal with this problem we're about to face. You should model their growth rate to be sure. Although you know nothing about this specific species of lanternfish, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. So that's probably going to be useful. So I'm going to write that over here in our file. So what I'm doing here with these double slashes is what's called a comment. So this is a comment, so that code won't run. So if I do something like this, 3 plus 3, and I click this run button, that will do nothing. That code won't go anywhere, it won't evaluate, but if I uncomment it, get rid of those slashes, will it print it? Probably not. I might need to print it out. So this is our first function we're using, console.log. That will print out 6, but if that line was commented out, it will print out nothing. So that's a useful way to write things that aren't JavaScript, so notes for ourselves. So my first note for myself is each lanternfish creates a new lanternfish once every 7 days. This process isn't necessarily synchronized between every fish. One lanternfish might have 2 days left until it creates another lanternfish, while another might have 4, so you can model each fish as a single number that represents a number of days until it creates a new lanternfish. Furthermore, you reason a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. 2 more days for its first cycle, right? So suppose you have a lanternfish with an internal timer value of 3, so it's going to spawn in 3 days. After 1 day, its internal timer is 2. After another, it's 1. After another, it is 0. And after another day, its timer will be set to 6 and create a new lanternfish with an internal timer of 8. After another day, the first lanternfish will have an internal timer of 5, and the second has 7. Makes sense. A lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. This is a point in many languages. We count from 0 instead of from 1, so the first item in a list will be referred to as the 0th element. This is sort of the difference between indexes and lengths. Not sure if that's any clearer, but I'm sure we'll find out very quickly anyway. The new lanternfish starts with an internal timer of 8 and does not start counting down until the next day. Realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfishes. That is our puzzle input. So we'll see that here. So normally this will be like a huge version of the file that we couldn't do manually. So I don't know how many that is, but probably a couple of hundred. So that's our actual input. But to start with, let's start with this input here. So I'm going to store this in a variable to help us. So let's say const input equals, and just store it in a string like that. So if I run this, so const means that this variable will never change. So input, it's not going to change unless we actually rerun the code, basically. And that's the same, well, similar to the keyword var or let. They're just different ways of declaring the variable with slight tweaks, but for now you could probably just use var for all of them and you'll be all right. Okay, this list means the first fish has an internal timer of 3, 4, 3, 1, 2. That's all good. And then here we can see the states over time. So on the next day, they all go down by 1. This fish is ready to spawn. So on the next day, it will create a new fish and then reset that timer to 6. Then this one's ready to spawn, so it'll create a new fish. Looks good to me. So really what I want to do is just get to a point where I can basically call a function and iterate these days. 0 becomes 6, adds a new 8, and each other number decreases by 1. Yet in this example, after 18 days there are 26 fish, and after 80 days there are 5,934. Simulate lanternfish and ask how many there will be after 80 days. So that's our final question. So that's our end goal, is reach 80 days. And then count how many fish there are, right? Yeah. Okay, cool. So first thing I need to do is find a way to iterate on the days and just make these fish basically age, right? So a string is not a useful way to do that. So we can't really access individual items of this input. So we can, as I said before, access one character. So the first character is referred to as 0, next one is 1, next one is 2. So we can see there that every other one is a comma, except for the last number there won't be a comma. So you can't just do every other number. So basically what we're seeing here is that a string isn't a useful data structure for this kind of work. There is one called a list, which is what we actually want. So what we're going to be looking to do is, instead of that, we're going to create a list which uses these square brackets, and then we can just go straight to comma separated values like that. So that's our ideal, but from our input function, I can't just paste this in here like that. And I certainly can't just write it in. Oh, I guess I can just write it in. But let's build it up from the string anyway, because then should I even do that? I could just read it in immediately here. It doesn't look great. Or it could be easier than reading it in from a file. It's actually quite small. I might do that. But what I'm going to do for now is I'm going to call the .split function, which is available on strings, and that will take what's called a separator. You can see it's telling me there, and that's going to be this comma. So what it's going to do is it's going to split that string into this list for me in the line it's read in. So if I call this now and I go input, you can see we have that list. If I do input, oh, they're all strings. That's kind of annoying. Input 0 will actually get me the first string or the first number. I'm going to map over them and this will come back later. But all I'm doing here is this takes a function. So it's going to iterate over each item in that list. And it's going to let me map it to something else. So I'm just going to map them all to integers. Do I even need to do this? I don't actually need to do this because I could just call it a list like that. So let's just do that and not deal with integers. So what we're seeing here is a difference between 3 in quotes and 3 as a number. So we can see that difference quite clearly. 3 plus 3 is 6, but 3 as a string plus 3 as a string is 33. So that's happened because it's assumed that, you know, if we had something like dog plus cat, there's no sort of implied mathematical addition of those strings. So JavaScript has decided that for strings, addition means concatenation. and that would be a problem if we were iterating over them. So I've just converted them to a number type instead of a string type. Next, we can iterate over these. So I kind of started doing it there with a map, but what I can do is I can say input.map, and this will take a function of a form sort of like an iterator, and then an arrow, and then something that will be returned in its place. So I could do like iterator plus 1, and well, that's not stored anywhere, is it? So if I ran this over here, we'd see that array returned with all those numbers incremented once. So what it's doing is it's saying let iterator equal 3 and replace it with 3 plus 1. Let iterator equal 4 and replace it with 4 plus 1. Let iterator equals 3, replace it with 3 plus 1. So it just continues doing that for everything. So this is going to be probably our most useful feature for this, because every day we're just iterating over the list and replacing numbers with new values. So that's going to help quite a lot. So I'm going to use that to just take away numbers, I guess. So let's do a little function called, I don't know, let's call it like, I kind of want to say like age 1 day or something. And then that's going to take our, it's not really input, it's going to take our, I don't know, spawn times, and it's going to return some new spawn times. Sorry, return. Let's just return spawn times. So that should take whatever list I pass in, it will just give it back. So now I can do age 1 day input is our current spawn times, and it should just return spawn times. So I can do age 1 day equals age 1 day, and it should just stay the same anyway. Ooh. I keep doing this. Right, there we go. And it shouldn't be const. Why can't it be const? Because, oh, that's a function. That should be input equals age 1 day input, and then the same issue, right? 11. So because it was set as a constant here, we can't change it. You should be able to overwrite the values as long as the size doesn't change. Okay, and let's do console.log day 1 plus input. So there we go, we've got day 1, it's the same, obviously that's just going to continue anyway. So let's call that day 2, day 3, but it will always be the same. So let's see what day 1, 2, and 3 should look like. So that should look like this. So we need to log out the initial state before we start as well, just to emulate that structure. Initial state. And it's always the same, but actually it should be taking away 1 every time. So instead of returning the spawn times, we can return the spawn times map timer minus minus. So that will decrement or do timer equals timer minus 1. So now they should just tick down. Return spawn times. So this one isn't being overwritten with this one. It should be passing in the input and then mapping over that input. So if I do this, spawn times equal 1, 2, 3. If I do spawn times, oh, does that not work? Timer minus 1. Ah, why can't I decrement? 1 plus 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 1. Maybe you can only increment. No, I don't know why that doesn't work. my age equals 28, my age plus plus. Not sure what's going on there, but there should be like a shorthand for incrementing in JavaScript. I don't want to get too distracted, but I don't want to. Plus plus. It seems to work here. My age. Maybe it did increment it, but I didn't write it anywhere. Anyway, let's go back to that. Right, so now it's decreasing every time, but when it gets to 0, it shouldn't be just taking away 1. It should be resetting it to 6. So let's add that logic next. So instead of returning spawn times map, we want a bit more of a complicated function in here. We can do that by wrapping this in these curly braces, and that basically gives us all the number of lines we need. So instead of just returning timer -1, we actually want to do like if timer equals 0, then we want to, we want to spawn new fish, and we also want to reset timer to 6. So let's just do that by returning 6 for now. Else decrement, I guess. Decrement, and then that's just going to return timer -1. And there should be no other case, right? Either the timer is 0 or the timer is not 0, so we're decrementing. So we should only be seeing at most 6 now. There we go. So we can see there our 0 becomes a 6 and continues to decrement. Our 0 becomes a 6, continues to decrement. Does that match up with what we're seeing here? So we've got 23201. We do have it. 121608. We do have, except for the 8, but that's fine. We haven't done that yet. So the timers are looking good now. We just don't have any notion of fish spawning. So let's spawn a new fish. So we can do this by adding. Ooh. I don't know if we can just push an 8 onto the end of this, or if that will get decremented. So this might get an extra decrement because it's already being iterated over, but we'll see. Spawn times. I can't. So while I'm mapping over it, can I push to it? Because it doesn't look like that's working here. Maybe if we don't return this, maybe if we do spawn times equals this and then return it at the end. Though I'm not particularly happy with that. Let's have a look. Nope. Okay. So this push isn't working. List.push JavaScript. So my hunch is that it should be pushing that item, but it's probably getting lost somewhere inside this map. So if timer is equal to 0, we're seeing that that is running because the 6 is there, but this isn't going anywhere in particular. I mean, it's certainly not modifying this object. So how do we do that? I'm genuinely not sure what the problem is here. This should be pushing onto this. This only exists in this function. I'm just going to log the spawn times in here just to see, as we iterate over it, is it actually changing? It is adding that extra 8. Though it's only doing it, what, on this? So spawn times is growing there, but what's getting returned to the map doesn't contain that. So we need to push on some extra. before we return it, we need to be pushing on those extra days. And that's the object that needs to be returned. So can I do... How am I going to do this? So every time, instead of pushing, I could like merge two lists. So I could say like new fish equals an empty list, then push onto the new fish. And then instead of returning spawn times, even though that does need to, I could call it old fish. So we've got old fish and new fish. One fish, two fish. Now I'm just wondering if I can just add two arrays together and see what that does. Because if that concatenates them, then this is fine. It sees them as strings. Well, there's going to be a concatenate. So how do I concatenate lists JavaScript? I should be calling them arrays as well, sorry. So there we go. We can just concat one array onto another. So we can do 1, 2, dot concat 3, 4. Okay, cool. So we can just return at this point, return new fish dot concat old fish. Let's get rid of that console log. Other way around, old fish should be first, then new fish. So all I'm doing there is the 8s have appeared at the start of my list instead of the end, which isn't what I want. Oh, no, that's right. That looks good. Is that what we've got in our... So here we go, day 3, we should be at 0105678, which we are. So that's pretty good. Next, we need a way to run this 80 times, right? Instead of doing this, we probably need to automate this. So let's do day count equals 1, while day count is less than 81. That needs to be in brackets, sorry. While day count is less than 81, console.log day plus day count plus I don't know. Plus, what did I do? Input, right? I just need to add a space in there, plus input. And then I need to age it each day. And then put this initial state before my while loop. That's not a variable. Let equals, let's let day count. And then I need to increment day count, which I would think I could do with day count plus plus, though that might not be correct. Okay. Wow. That doesn't look right. Is it just... What is it doing? Input age 1 day. Let's set this to 3. Okay. It's kind of looking right, but those lists looks really strange, like they were sorted or something. I don't know, that looks good. Let's check it against day 9. 12160. 12160. Okay. So why is that? This looks really weird, but it's like it looks like it's been sorted, and I don't know why. Day 80, like it starts out normal, but then it kind of just becomes like a big, increasingly large sorted list, which makes me think that I'm not resetting one of these, like when new fish isn't even defined as a variable, so that's not a good start. So that should be let new fish equal an empty array. Is that all I need? No. New fish is being pushed to, concatenate them. I guess similar issue for old fish. Old fish isn't defined. Is that the problem? That's really weird. That's definitely not right. So something really weird is going on there. Input equals well, we can sanity check it by seeing if there's by logging out the number of fish as well. So let's do the number of fish is the length of that list. So number of fish, plus input dot length. So it should be like, how many long? It should be like 6,000 long for these 81 days. Input.length is not a function. Is it a property? Huh. So the number of fish is correct. Is that just because as it grows, there's more fish being created at each stage? And so it just gradually creates larger counting down groups. That kind of makes sense. It looks really weird, but I guess because it grows exponentially, you should see that. So it's all fine. So nothing wrong. That's correct. So we should be at a point where we can try it now. The puzzle input is so small that I don't even need to read in a file. I can actually just paste it here. And that should give us our first attempt. It's quite slow. So this is where, at this point, I have no idea how long this is going to take. I guess I could stop it. Ooh. It's slowing down. So we're logging out way too much, right? We don't actually need to log everything out, and that's one thing that can slow us down a lot. The other thing that will slow us down a lot is if we use an algorithm that isn't efficient. So what we're doing here is we're iterating over every single item in the list every single time and decrementing it. There might be a more clever way of doing that. For example, we know there's going to be 80 days. We could look at each one and figure out, okay, in 80 days, this will spawn this many new fish and things like that. But I think that adds its own problems, to be honest. So for now, let's not log out the input and let's just log out the day count. And then at least we can see how quick we're moving. Oh, just by doing that, we save loads of time. So it just shows how I was asking, even in that small list, by the end, we were logging out an extra 6,000 fish spawn timers that we didn't need. That's one way to speed these things up anyway. So 396,210. That's our answer for the first part. Let's submit it. And there we go, 1 gold star. That feels good because I didn't get any for the last 2 weeks. So I'm glad we actually made some progress this week. Let's go on to part 2. So normally part 2 will sort of punish us for something we did in the first one. So suppose the lanternfish live forever and have unlimited food and space. Would they take over the entire ocean? After 256 days in the example, there would be this many fish. How many days would there be after 256? So it sounds like it's trying to punish us for not being computationally clever, basically. And that's not really surprising, but we'll see. I mean, that didn't take that long to run, but they did give us the clue at the start, that it's going to be exponential. So we should have been prepared for that. Maybe we can refactor it. We've got half an hour left, so we can give it a good go. But let's see what happens. So instead of that, we want 257. Let's see how long that takes to run. So we can see already it's getting wow. Even with those 5 inputs, we're really slowing down computationally here to a point where it's probably not going to get to 256 in any reasonable time, which sucks because that means we need to change the way we've done everything to something that's slightly more computationally correct. And we can see like already from these 5 fish, there are literally millions of fish coming. We know it's going to be 269 million fish. So what are we at now? 25 million. So we're not even like 10% done. We can probably estimate this. This will probably take about 10 minutes to run, and we're not even using the big fish data set. So I'll show how quickly that's going to grow. It's not going to be great. We've actually broken the runtime. So similar problem, starts out really quick, was great if we were only asking for 80, but we're not only asking for 80, we're asking for 256. So it's probably not going to finish in any reasonable time here, but this one's getting slow even earlier. So we need to do something computationally clever here, which I'm not confident or happy about doing live, but let's have a look. So what can we do that is better? Oops, I need to stop running that by default. Right, let's not count up to 200 and anything days. Let's just go to 100. And I'm probably going to get paint up. So at this point, we've got a number of fish with different days until their spawn times. We need to decrease the number of fish. Well, we don't actually need to decrease. My hunch is that, by taking one away every time, we're kind of hurting ourselves, when really all we need to do is figure out how many of them are zeros and find a better way of doing that, and figure out, because those ones will all spawn new fish in the next one. And then we don't really care about the other ones until it's their turn to spawn, right? Like, we know already that this one doesn't need to run until day 5. This one doesn't need to run until day 7. So we could be like filtering the list, but to filter the list, we'd have to check every item anyway. So it would be exactly the same as overwriting the list. So that doesn't seem any better either. And I guess, like, my hunch is that if I know we're doing 256 days, so I should know from the list, at most there are fish in here that are 8 days, and after that they're mostly 6 days. So I should be able to say, each fish created on day 1 will produce a certain number of fish, but I also need to know the day that each fish is produced. So that doesn't really make sense either. Maybe I could see it as a tree. I normally find with these, if you can see them as a tree, or if you can sort them somehow and benefit from that, that's how it works. So if we have this one fish, it's obviously going to create new fish at varying points. It's only ever going to create one fish, actually. And then that fish is going to create new fish, while this fish continues to make another fish later. So that might make them on like the 7th day and the 1st day. This one will make them on the 9th day and also the 15th day. And this one will also make one on the 13th day. So this to me seems like the way we do it, right? Like, as soon as a fish is created, we can figure out all the fish it's going to create and on what days it's going to create them. Then we can, that seems to me that's the way we're gonna do this. But I'm also aware it involves like climbing down this tree, and that means that there's going to be like millions of these trees climbing, which makes me think this is going to be like a recursive problem, which is also going to be crazy. So let's maybe forget about dealing with new fish, and for now let's just try and deal with like how many fish this one fish is going to create in its lifetime and what day it's going to create them, and then go from there. I'm not confident this will get finished, but let's give it a go. So let's not spawn any new fish. We just need to figure out how many fish this will spawn. And we need to get away from... Do we need to get away from this notion of aging one day? Maybe I can figure out like const calculate. Let's do get birth days equals a spawn time. So let's try and do it for each individual fish. And that's also gonna need the number of days. Oh, it needs the number of days remaining in the cycle. Days remaining. Is this even better? It must be better. It's better than counting everything all the time, potentially. Right, so the easiest... this sucks. Okay. Let's get this out of here. Let's comment all this out. Let's just start again. Right, so our simplest input, let's keep it simple. Our simplest input is that today is spawn day. Yippee! And I want to calculate all the days that this fish will spawn in the next 256 days. So that is going to be... Right, I can just add them up, right? I can go like spawn days. Oh, let's call it spawn day. Spawn day. Spawn days is going to be a list, and I need to declare it as such. So the first spawn day is going to be log get spawn days. Days spawn time is, let's say, input 0. Days remaining is 256. And while spawn, while input is we need like a counter as well. So let day count equal 1. And then let's say while day count is less than 0. No, less than. Let's do let total days equals 256. Let day count be less than total days. While that's happening, we want to push the day count into spawn days. Spawn days dot push day count, and then we want to increment total days. Total days. No, we don't. We want to increment day count. Day count plus equals 6. So that will increment it by 6, which is every spawn day. And that should stop the while loop. So we should get all the spawn days. Let's reduce it from 256 as well to at least here. Let's do it to the 18 days. I mean, day count is not defined here. That should be uppercase. And it didn't return anything because I didn't ask it to. Return spawn days. Okay, so the days that a fish that is spawning today will spawn are 1, 7, and 13. Does that add up? We don't actually have an example of it here. Maybe we should... I mean, I think that's fine. So day 1, it's at 0, it gives birth. Day 2, it's at 6. 5, 4, 3, 2, 1 spawns at 7. So that seems fine. So the next thing to do would be to make the list more complicated. So instead of 0, let's do 0, 0. And now it'll still work, but it's only giving us that first one. So the spawn days need to be for each item. So now we need to map and create the spawn days. So I need to do input equals input.map, and we're going to map the spawn time to get spawn days, spawn time, comma, days remaining is total days. And then I want to console log the input instead, so that should give me two identical arrays with the correct spawn days for each fish. And now each fish that's created has sort of like edges in a tree, and then we can traverse. Why is this better? Because we can traverse the tree. It's because we don't actually have to do the maths for everything. We already know the days it's creating a fish on. But then would I not just be reducing? No, because I can crawl into each each item in this list. If I went into it, would be the new total days for that item. So we can basically do this recursively until, yeah, and the day count will be over total days, so it should terminate. Yeah, it's just a recursive function. It's recursive like tree crawling. That's harsh. But yeah, it will be better. But I won't enjoy it. So this is it really. We just need to keep crawling down the tree. So the base case will be when the day count is exceeded. So right, so we need to basically, this needs to be a recursive function. So in the base case, the number of spawn days will be what? This will be like 6, so nothing will happen. So that's the base case. Oh, one fish is born on the first day. That should be 6. Oh, I haven't even thought about how new fish spawn with 8 days in their timer as well. That sucks big time. But let's figure that out anyway. So it shouldn't be spawning on the first day. Is it always 0? Is that why? Input, where do I say input 0? I don't, I say input 6. Total days, so 6 is I didn't even check if okay, so our next the next thing we need to test is whether this works at all, which it doesn't. It will just always say 1 because we never use the input in anything. So if, yeah, for this fish, if it's not on a multiple of 6, then this plus 6 is wrong. It should actually be 6 plus the day. And that's why it made sense. So when it was 0, we were actually doing 6 plus equals 6 plus 0, so it didn't matter. So that gave us the correct answer, 1. So let's do total days 20 again, just so we can see that. So it should be giving us 1, 7, 13, 19. Ooh. So if it was 1, there's no difference there. Yeah, but it should be doing plus 1. So it should be adding in our input, which in this case is spawn time. Plus spawn time. Okay. Is that all I need? There we go. So now I should be able to give it 0, 1, 2, and I should get different. Yes. Okay. Now next I need to crawl down them until the day is finished, so I can like return them all up. So again, let's keep it really simple. So let's do 0, let's do 10 days. 1 and 7. Let's do that. So now once we've got that 1 and 7, so from our initial fish, So we've got this fish with a 0. That is going to create a new fish on, sorry, it should be a 1, day 1. That creates a new fish on day 1 and a new fish on day 7. And if we had 10 days, this fish has the ability to make a new fish on day 9. And then we're done. Then we hit 10 days, right? So that number of fish needs to come back up to here. And this fish needs to return 2. So we just build up the number of fish it has once the number of days are exceeded. So this should be returning, while we're crawling, we shouldn't be returning anything. But we do need to actually like summarize it at the end with the number. So it needs to map again, basically, which is not going to happen. So let's see what does it do. Do I just need to, for each, do I need to map over it again, like a map? No, I need to map over this one, .map. And just run the exact same code again in there. Okay, so that worked. So we now have 3 fish, which is what we should have for this number of days. But I can't keep running map every time I need to go a layer deeper, basically. So it needs to be sort of like self-recurring, and we do that by calling it in here. So if, okay, so if we need to return them, we only return when, no. So what we need to do is call get spawn days in here on our spawn days, like this. So we need to go get spawn days, days remaining again, and that will eventually terminate, right? This will eventually terminate and then return back up here. And let's just store this in, I don't know, number of fish equals, oops, no fish. Will that terminate? No. Day remaining is not defined because it should be days remaining. So it's not terminating now because I'm not checking if days remaining is less than day count. No. What am I passing in here? Days remaining isn't what I should be passing in. Days remaining minus day count is probably what I should be passing in, or something like that. And then that days remaining is my new days remaining. Day count wouldn't be 1 as well. Day count will be whatever like the spawn that I'm passing in is. Spawn. Oh, I don't like this. And we need to do this for everyone as well, not just the first one. But for now, let's just do the first one. So let's do spawn days 0. That instead needs to be mapped over for each. Just a note to myself to do that. Oh, this is not good. I've not written a recursive function for like 2 years. If day count is less than days remaining, then we should iterate again. And otherwise we should return Days remaining? I don't know. Return. Oh, this isn't good. That might terminate now anyway. Let's see if it actually runs. Okay. That's only running because I'm doing the map twice though. So this is the initial case with only one depth level. But it should be doing this, but it's not returning anything gained from that. So do I need to do like spawn days equals that? No. I'm really guessing here. This could have been better prepped, but this just goes to show how hard these things can be anyway. Total days. Ah, it's missing a bracket. Interesting. It did. Is that correct? No, because it should have another fish. So we are just using the first fish there, whereas this should be running for every item in the list as well. So on the spawn days, it should be like a for loop over spawn days dot for each spawn day, and then we do if spawn day is less than days remaining, then I call get spawn days on spawn day with the number of days remaining minus the day count, minus the... Is it minus the day count? No, right? Does it need the day count? No, that is right. And then what do I do with that? I want to return that eventually. So I want to return that, and I should build up. Ah, I've lost a fish. Where have I lost a fish? So it should be... Let's console.log spawn days a lot more. And let's do it in here as well. And see what we're getting. So there should be... It's somewhat looking correct, right? There should be a fish spawned on day 1, a fish spawned on day 7, and a fish spawned on day 9, which might be covered there. Anyway, that's been an hour. I'm surprised by how somewhat competent that recursion from nothing is not easy, right? Recursion, if you're at university, you'll have multiple hour-long lectures on recursive functions and how powerful they are. And it is what we needed, and we could have done it from the start, but we didn't need to because it was only a sort of, well, it was an exponential problem, but without exponential problems. But yeah, I'll leave it there. Thank you very much, everyone who came and watched, and I'll see you all next week, hopefully. Bye-bye.